Hello, and welcome to Backer Breaks It Down. In today's episode, we continue to simplify radical expressions. We are going to focus on quotients, however. And this cartoon, well, kind of shows you exactly what I mean when I say quotients. If you look at Woodstock in the last box there, 7 square root of 2 over the square root of 6, that's a quotient. Okay, so let's check out some methods and tricks that we can use to do this. So we can use our division property of square roots. So if I have like the square root of a over b, I can simply split this up. Say this is the same as the square root of a over the square root of b, and look at the numerator and denominator separately. That's like one trick. But honestly, sometimes looking at it as the fraction a over b is helpful too. Okay, so just be aware you can go both ways with this. Here are some tricks when simplifying quotients involving square roots. Definitely look for perfect squares. So like this first example here, I had the square root of 16 over 25. So maybe I look at them both separately, like square root of 16, square root of 25. The square root of 16 is 4, the square root of 25 is 5. Done. That was like super easy, right? Okay, so some other tricks. So one of the tricks is to try simplifying the fraction inside the radicand first. Okay, and so that's what we're doing here. So like 32 over 50, not perfect square, right? But they're both even. So if I go like 32 divided by 2 and 50 divided by 2, that's all I'm doing. So I'm doing nothing with the square root right now. What I get is I get 16 over 25, and this is like my new inside. And then I can split it up. Square root of 16 over square root of 25. Square root of 16 is 4. Square root of 25 is 5. Okay. So try simplifying the fraction inside the radicand first. That's where like maybe keeping it like that is good. Okay. And then another trick, it says look to see if maybe like the numerator and or the denominator, maybe only one of them is a perfect square. Okay. Because honestly, if the denominator of the radicand is a perfect square, then excellent. Okay, so like in this fraction here, square root of 10 over 81, it's like, wow, square root of 10, square root of 81, write them separately. Square root of 81 is 9. And so I don't have to worry about the denominator anymore. The square root of 10, I'd be like, can I like reduce that? And if I can, I would. And if I can, okay. All right. The bottom line is when we are simplifying a quotient, you cannot have a square root in the denominator. It's not allowed. The numerator, it is okay, but the denominator, never. Okay. So let's see like these methods in action, okay, before we talk about another method, all right? And so we definitely want to be on the lookout for perfect squares right away. If there aren't any perfect squares at all right away, then we'll try simplifying the fraction, okay? So looking at number 5, I see the square root of 9 over 4. And it's like, oh, so square root of 9 over square root of 4. Those are both perfect squares. Excellent. This one's easy. The square root of 9 is 3. The square root of 4 is 2. And look at that. I'm already done. No square roots on the bottom. That's the way we like it. So when we look at number 6, we have the square root of 11. That ain't going to work. Square root of 49. Ooh, that's a perfect square. The square root of 49 is 7. And so on top, I still have the square root of 11, but that's okay because I don't have a square root on the bottom. So this is all good. Now the square root of 90 over 5. Yeah, neither one of those are perfect squares. So I'm going to do that thing where I'm going to simplify the fraction inside the radicand first. That's what I'm going to do here. So if I go like 90 over 5, well, this is nice because it's simply going to be 18. like 18 over 1, but let's face it, that's 18. And then I can simplify that using like my multiplication rule, because 18 is like 9 times 2. And then the square root of 9 is 3, and the square root of 2, well, that's all you can do. Okay, so these were like really easy, right? But remember what I said. I said we are not allowed to have square roots on the bottom. So what if like none of our denominators in the square roots down there, what if they were still there? Okay. And so there is a process called rationalizing the denominator. Okay, and this is what we do when we have that radical in the denominator and it just isn't going away using our tricks. Okay, so what we're going to do is we're going to multiply both the numerator and denominator by the radical in the denominator. So here we're working with 5 over the square root of 10. So using the process of rationalizing the denominator, I'm going to multiply the top by the square root of 10. I'm going to multiply the bottom by the square root of 10. On top, because I have an insider and an outsider, they don't mix, I simply get 5 root 10. On the bottom, the square root of 10 times the square root of 10 is 100, and the square root of 100 is 10. So now I have 5 root 10 over 10. Now it says that after I do that rationalizing part, I should see if the outside numbers reduce. So they're talking about the 5 and the 10. They do reduce down to 1/2, so I would do that. So my final answer is the square root of 10 over 2. So maybe pause this, look that over, try 8 and 9, and then unpause, check back in. So in number 8, I have 5 over the square root of 7. So 5 is an outsider, 7 is an insider, so they're not going to mix. Okay, so I can't do any of my tricks here. So I'm going to go straight to rationalizing the denominator. So I'm going to multiply the top and the bottom by the square root of 7. Now on top, I can't mix an insider and outsider, so I simply get 5 root 7. On the bottom, square root of 7 times the square root of 7, well, that's the square root of 49, which honestly, let's face it, is just 7. So like, it seems kind of silly to go doing this whole like middle step here when I can just really go from square root of 7 times square root of 7 is 7. Like you can totally do that, okay? Looking at number 9, I have 6 over the square root of 18. So an insider and outsider, and they don't mix, okay? So I can rationalize the denominator. So I can multiply the top by the square root of 18. I can multiply the bottom by the square root of 18. On top, I get 6 root 18. On the bottom, well, it's simply going to be 18. Now on the outside, I have 6 and 18, and if I can reduce that fraction, I am expected to do so, and I can. Both of those are divisible by 6, so like this would cancel and just become 1, this would cancel and become 3, so I have the square root of 18 over 3. Now what about the numerator? Because I should check and be like, can I reduce that? And the answer is yeah, the square root of 18, well, that's the same as the square root of 9 times the square root of 2. The square root of 9 is 3, the square root of 2 is all you can do. So I am able to continue to simplify, all right? So 18 is 3 root 2, and this is all over 3. And if you're like, would the 3's cancel? The answer is yes. So we ultimately just end up with the square root of 2. So it seemed like there were a lot of steps here. So I want to show you another way we could have tackled this. So we have 6 over the square root of 18. So I feel like I just kept simplifying and simplifying and simplifying. And it never seemed to end. So like, if you were thinking, hey, the square root of 18, like I've had to do that before. Can I simplify that right away? And the answer is yes. So we know the square root of 18, because we just did it, is 3 root 2. So I can do that right away, because maybe it just makes numbers smaller. And notice that here it does. Okay, and then 6 and 3, the 3 would cancel out, leaving me with just a 2 on top. So now I have just a 2 on top and the square root of 2 on the bottom. And then I can rationalize, multiply the top by the square root of 2 and the bottom by the square root of 2. That gives me 2 root 2 all over 2. And yeah, the 2's would cancel. So I just have the square root of 2. So you could do that as well. And that's simplifying quotients. So definitely look for perfect squares right away. If you don't have perfect squares right away, try simplifying the fraction inside the radicand first. Maybe that will produce a perfect square, or at the very least, make your numbers smaller to work with. Just remember, no square roots are allowed in the denominator of your final answer. So if you need to rationalize the denominator, you should do that. That involves simply multiplying the top and the bottom by the square root on the bottom. And that's how Backer breaks it down.